Alright, boys and girls, welcome back to the Drive-Thru 4 Remix. Alright, this is going to be a long video, so I will go as quickly as I can. Some things that I want you to understand. We've got two sets of data here that we're going to plot separately. And it might be easiest if I plot these to start and then just turn off the video for a second and plot the rest of them. And I might encourage the students to do that on their own as well. Okay, so we're going to have men in blue, women in red. You can see a large discrepancy here between the male data and the female data, and this is why data is important. This doesn't seem equitable or fair to me. I think a man and a woman deserve the same pay for the same job done, I should say. But this is how you make change in the world. You look at data, you present facts to people of power, and you ask them to make adjustments. So this is why this is an important chapter and why we're spending so much time on it. It's important to understand that they want you to set the year 1991 as 1. So this point is the point 1, comma, 38,000 over 1. I shouldn't do that. Over 1, up 38,000, right there. Over 2, down just a little, down to 37,000. Over 3, down just a little bit from the prior one. No, up just a little bit from the prior one. Gosh, darn it, Carson. Over 4, up to 38,200. So, just to there again or so. I know these are not completely accurate, but we're going to get a correlation. 5 still just dropped a little bit. 6 took a $200 jump. 7, we're finally up to 40,000. 8, another big jump. Up to 42,000. Sorry, that should be 8. Right there. 9. Up just a little bit. Just a little bit for 9. 10. Down just a little bit. 11. Down again. 12, down again. 13, up a bit. 14, up again. Up to 41. And then 15, down a bit. All right. So there's the male lines. I'm going to pause the video. You guys can do the female lines without me. I'll do the same thing. Okay, so, yeah, I did my best. Let's answer the questions. What is your estimate for the correlation coefficient for these data? What do you think about that? Which one looks more like the data points form a straight line? I agree. I think the female ones line up better than the male ones do. So if I had to make my prediction, this might be a decent line of best fit for the blue one. Do you agree that I have some points that are above, some points that are below, and some points that are on? Yep. Well, if I look at this one, I agree that I still have some points that are on, some points that are above, and some points that are below, but I don't think the red points are as far away from the line as the blue ones are. Do you agree? And what is the best correlation coefficient we could possibly have? So I'm going to say that the red one might have a correlation coefficient of like 0.8, where I think the blue one might be, take a guess, Carson, 0.6. That's fine. These are just guesses. Okay? Next page. Next page. All right, estimate and draw lines that model each data. We've done that. Describe how you estimated the line for men. I pretty much tried to have the equal amount of points above, below, and on the line. Same with the women. Okay? Write the equation for each of the two lines in slope-intercept form. We could do that. Let's go back to our lines. It looks like the blue line has a y-intercept of about 36,500. And if we went rise over run, if we went over 10, if we went over 10 from there, we went up. Each one of these is 100, so up 1, 2, 3, 4, 5. Okay, so I'm going to guess that the line for the men is about y equals 500x plus 35,500. Okay, so now you do the red one for me, Carson. Estimate the y-intercept. How about 15,100? No, hold on. Each one. Each one's 100, right? So that should be 16,000. 16,500. And if we did the slope the same way, just go over 10. It's gone up. Oh, so this is, it's gone up $1, 2, 3, 4, 5, $600, right? $6,000, and then you divide that by 10. Good, that's how I got it. So that's about 600x. Okay? Just to reiterate how I did that, I went from the point 0, 16,500. Uh-oh. To the point 10, 22,500. So that's a change of 6,000 in 10 years, which is where I got the 600x from. Does that make sense? Yep. All right, let's go back to this. Write the equation. So let's the blue equation was 500x plus 35 plus 35,500. And do you remember what the red one was off? It was y equals 600x plus 16,500. Very good memory, Carson. Okay. Use technology to find the actual correlation coefficient for men. Here we go. Back to the graphing calculator. Give me a second. I'll pull it up. Okay. The point of the video is really to help you, so I think I need to help you with your graphing calculator. Notice my lists are empty. You might need to walk up to me and I'll show you how to edit your lists, because you're going to have to delete them. Okay? In the first list, I can type it in by memory. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? Now L1, we're going to have to pull up the data chart. Oh, all right, hold on. This should be an 11 here. All right, L1, we are going to, since they asked for the men's list first, we're going to do that first, Carson. So let's get back, whoops, to this. And if you don't mind, I don't know how to do this. This is annoying. All right, can you read me from here to here. Ready? 38,000. 38, you can read it like that. 38145, enter is what I want you to tell me. Next.
37528, enter.
Next.
37712, enter.
Yeah.
38215, enter. 38607, enter. 38894, enter. 40406, enter. 42240. 42580, enter. 41996, enter. 41280, enter. 40595, enter. 40987, 41464, enter. 41196, enter. Up 1 second.
41196, enter. No problem. All right, good job. We did a good job there. So now, we're probably going to do a regression line here, and I'm going to need your help to turn that settings back on. So it gives me. Do you remember how to do that? So let's go to quit now. They don't erase the list. Let's go to stat, and let's calculate.
No, you got to go to catalog.
So, okay, but all right. So that's fine. We'll go to catalog first to turn on the diagnostics. You don't have to do this every time. I do, because every time I shut this computer down, it turns this off. It resets it. So I gotta go to diagnostics on and then hit enter. Come on. Come on. Come on. Come on. Diagnostics on. Enter. Enter. You got to hit enter and get it done. All right, now we are going to go to stat, and we're going to calculate a linear regression line. List 1, list 2.
Go down to
Go down to what? Calculate. What?
If you wanted to get it scattered for you.
We don't want that. We just wanted that. Is that what we wanted?
Yep.
So what did they tell us?
Told you that the regression line is about it's 0.79.
All right, so the correlation coefficient is 0.79 for the boys. We weren't bad.
No.
Okay? And the girls, we're going to find out next. So let's go back to our list. Stat. Edit. And now in this column, we're going to put in the girls' information. You ready? I'm going to pause this. You guys can do this on your own. Okay, so you've seen that now I've typed in our female data into a new list, and I'm sure later on they're going to ask us for some information. So let's go back to the questions. Use technology to find your actual correlation coefficient for men. It's 0.979. Also, if you notice, we had our slope a little bit too high, but that's fine. We were kind of close. Okay? So that means that what is the relationship between income and years for men? Well, the income is increasing. The correlation coefficient doesn't tell us that. It just tells us that we can trust the regression line that our calculator gives us. What was the actual correlation coefficient for women? Let's go back to the calculator. Let's go to quit. Let's go to stat. We want to calculate the linear regression. Now we want this one to be L3. So I hit second 3, and I come down here to calculate. Wow. We were right. The female correlation coefficient was 0.96. Excuse me. Let's go back to my calculator. What do the correlation coefficients of men and women tell us about the data? It means that we can trust our regression line for women more than we can trust it for men. The data is more in line with our line. I'm going to finish this up and publish it. Have a great day. Okay? All right, use technology to calculate the linear regression for each data. Add the regression lines to your scatter plots. So the linear regression for men, well, let's answer the women one first. It's y equals ax plus b, so it's 464x plus 18052. This is for women. $18,052, and let's get back to the calculator, and let's quit, and let's go to stat and calculate a regression line var. Now we want to change this back to L2 and enter. Come down here, calculate it. And we've got y equals 312x plus 37,269. $37,629. I don't even think I said that right, but that's what it is. Okay, I'm not going to plot those over, but you can understand that we were a little bit. Our slope was a little too high in both cases, and our Y-intercept was very close. I'm proud of that, but we were given that data, so it should have been close. Compare your model to the regression line for men. Now, the slope, the answer to this question, what does the slope mean? This is very important. Take a look. Which slope is bigger, the blue one or the red one? The red one. So what that means is that the women's income is increasing at a faster rate than the men is, meaning their income is catching up, and that's a good thing. Compare your model to the regression line for women. What does the Y-intercept mean? Well, that means that the men in 1990 started significantly above the women. So the women have some catching up to do because of the inequity of the data. Moving on, compare the regression lines for men and women. What does the lines tell us about the income of the men versus the income of the year? I think we've spoken about that. The gap is being closed at a very slow rate of about $150 per year. What do you estimate will be the median income for men and women in 2015? Let's just go back to our graph for that. That's the best way to get that. In 2015, I think the women will be at 26,000 and the men will be at 44,000, 26 and 44. Um, 26,000 and 44,000. Now look, I think this is about ready to be the end of the data, or about the end of the video. Oh good, I thought I skipped something. Good enough. Hopefully that helps you use your calculator, helps you understand what these numbers are telling you, helps you understand that this is actually like the stuff that you're learning that can be applied to everything. And that's why it's really important. It's also good that we're doing it right before the air test because it's certain to be on there. Hope that helped. Boom!